All of you. Today I am here with the part 2 of the causes of corrosion on board ship and what are the various affected area related to them and what preventive measures, routine maintenance we can carry out with this. So in this video, I will be describing the remaining part. Okay, so let's start. Okay, now this is the in list of all causes which is basically doing the corrosion on board ship. So first four I have already described in part one. So in this one, I'm going to describe the last three. That is your MIC, microbiological influenced corrosion, mechanical wear, which causes the corrosion, and chemical exposure. Okay. Now this is MIC. MIC is microbiologically influenced corrosion. So how these microbes will influence the corrosion part? So the number one is your biofilm formation, differential aeration, and metabolic byproducts and acid products also. Acid products. So they are going to impact in these ways. Biofilm formation is the first part. Microorganisms attach to the metal surface and form the slimy biofilms. These films trap the moisture, salt content, and the nutrients on which they grow and creating the microenvironments for them. It causes the differential aeration. Under the biofilm, oxygen level will drop because it consumed by them, and while surrounding areas remain oxygen rich. So there is a differential aeration, and this is going to cause the formation of corrosion cell, leading to the pitting part. Then metabolic byproducts. When these microbiological impacts or influence corrosion happens, then sulfate reducing bacteria SRBs produce the hydrogen sulfide, which reacts with iron to form iron sulfide and accelerating the corrosion part. And this localized corrosion also we have seen earlier, that is the acid production. Some bacteria generate organic acids, and that is going to do the localized attack on protective coating and the other metal surfaces. So that's how they are doing the corrosion on board. Where these happen most? Ballast tanks, bilges, fuel and water system, and cooling system, where you have the growth of possibility of growth of microorganisms. Ballast tanks, you have the stagnant water. This gives the enough nutrient for the bacterial growth. Bilges also accumulated oily water and poor drainage system. This is also promoting the MIC. And fuel and water systems combined, the microbes thrive in the storage tanks, pipelines, leading to the internal corrosion of these. And cooling system, biofilms in seawater, cooling lines reduce efficiency and corrode the pipelines. So this is something which is your part which is going to microbiologically influence the corrosion. What are the prevention part? It is very important to discuss in this matter how MIC can be controlled. So what should be the strategy and how this is going to help you to reduce corrosion? Regular cleaning. Regular cleaning will remove biofilms and deposits, and if it is removed, then of course the MIC impact will be less. Biocides, the chemical treatment. Chemical treatment will kill the microorganisms, and which is going to affect the tanks, pipelines, and the internal places. Coatings, you have to have the sufficient coating to prevent the MIC impact. A specialized anti-fouling paints. This is basically for the hull structure. Will resist the microbial attachment to them, and they are not allowing any growth and prevents the hull platings. Cathodic protection, yes, this is your ICCP. Reduces the electrochemical reaction with the biofilms. Basically, this also affect, we will discuss in detail the ICCP part also in the another video. Monitoring. Routine sampling of the ballast fuel tanks for the microbial activity is very important, and if you found that, then you can remove. Mechanical wear leads to the corrosion. Coating damage, erosion and corrosion, fretting corrosion, synergistic effect. We know that mechanical wear basically removes the protective coating. Paints, anti-corrosion coatings, oxide films are worn away by the friction, and which is also impacting abrasion, erosion, and then this bare metal is exposed to the steel and quickly Steel is due to the seawater exposure, the things will start. Erosion and corrosion. Fast moving seawater particles, any cargo also moving inside the pipeline, bends are there, so they are impacting and the protective layer is being removed. And they physically erode the surface, thinning the metal and making it more vulnerable to the chemical attack. Or you can tell that the protective coating is gone, the bare metal is exposed, and the corrosion will start. Fretting corrosion occurs at the joints of fasteners where the small vibration causes repeated rubbing, breaking down protective films and leading to the localized rust. So this is basically found on the engine room parts also. Basically, you have the fittings, and on deck fittings also it is very evident. Synergistic effect. Mechanical wear and corrosion together causes damage which is faster than the other process alone. Okay. So this is also going to impact like largely. What are the parts where you will found this mechanical wear corrosion? Propeller and rudder, basically where it is moving parts. High speed water flow erodes the protective coating and leading to the fitting part. Sea chests and the pipelines. It is not only the sea chest and pipeline, any other pipeline, like cargo, I told you, the oil as a cargo, crude oil as a cargo. So lots of abrasive particles are there. So they are basically eroding inside the internal coating, and this is basically going to cause the internal corrosion, accelerating the corrosion. Deck machinery, winches, cranes, and moving joints suffer from the fretting corrosion. And hull plating near waterline. Near waterline, you have the oxygen availability also, electrolyte availability also, the constant wave action and impacting wear away the coating. Chemical exposure, acid attacks, alkaline attacks, salt and chloride chemicals, fuel and oil contaminants, cleaning agents. So all these are acid like sulfuric and hydrochloric acid basically dissolve the protective oxide layer and react directly with the steel, leading to the rapid thinning up. This is something which is very important. Alkaline attack, storage bases, caustic soda can weaken the coating and cause the stress corrosion cracking. So we have to know about the various types of corrosion. In that one, you will understand nicely. Salt and chloride chemicals. Chloride will penetrate the protective film, causes pitting and crevice corrosion. Here we have the stress corrosion, crevice corrosion also coming into part. Fuel and oil contaminants. Sulfur compound in the fuel and causing the formation of acidic byproduct that corrode the tank and piping. Cleaning agents. Harsh chemicals used for the tank cleaning and maintenance can strip the coating and expose the bare metal. Basically, what happens, the whatever things which can cause the formation of acid or the strong bases or the salt and chloride based chemicals, so they are basically removing the protective film. And then what happened, due to this chemical exposure, the protective film is gone, the bare metal is exposed, and that's how the problem starts, the corrosion starts. What are the common area? Cargo tanks, chemical tanker. We have basically the steel coating, or you can say the structure is made up of the stainless steel. The things are less, but then also we have the impact of the chemicals. Ballast tanks, chemical residues, seawater mix, creative, aggressive environment, fuel system, sulfur-rich fuels, condensate causes the acidic formation, deck and superstructure, if the chemical spills, cleaning agents which we are using for the decks, the cargo holds also, the pipeline which is carrying all these chemicals, they are also getting affected. So it's not only deck and superstructure, we have the cargo holds also included, and we have in the pipelines which is carrying this chemical water also. Engine room machineries, the lubricants, coolants, and the chemicals also used in the engine room. So whatever the pipelines, tanks, which is being carrying all these things, they are also getting affected. So they are causing the localized corrosion part. How it can be prevented when we talk about the prevention and control methods. So we have discussed fully, and now we are talking about the prevention and control. So methods, how it works, and applications. Basically the places on board ship. Coating and paints everywhere it is required. This is going to create a protective barrier, preventing the oxygen contact and seawater contact also. Hull, deck, tanks, engine room, accommodation, superstructure, everywhere this is going to. We have a huge budget for paints onboard ship. Cathodic protection, yes. Sacrificial anodes is there, and we have zinc cathodes, which is being used. Aluminum rarely used, yes, but it is used. They are corroding themselves and protecting the steel. Hulls, propellers. We have in sea chest filter also we can see that, and we have ICCP also fitted. Corrosion resistant material which is being used. The stainless steel, specific alloys, pipings, fittings, even the chemical tank, like we have seen the chemical tanker, the tank structure. Regular maintenance, very, very important. We can avoid this MIC, we can avoid this chemical attacks, regular maintenance, cleaning, inspection, and repainting wherever is required. So that is also all the ship structure is going to be impacted. Environmental control, yes, dehumidifiers, ventilation proper, so it is going to control the moisture part, engine room, storage tank, accommodation area also. So if you do that, these are some of the categorically specified part, and this is going to prevent this one. If it is not taken care of, a structural weakening, yes, it is going to waste the material. Hull will crack, thickness will reduce, leakage will start, and one day you can have the catastrophic failure also. Reduce the efficiency, fouled heat exchanger and pumps. These are the places where you have the efficiency will reduced, the water flow will reduced, and maybe you have the pipeline leakage and all. High costs, expensive dry dock repairs and steel renewals. This is going to increase if you are not taking care of wastage of material. Safety hazards, compromised watertight integrity, a fire risk from the weakened piping. So this is also a safety hazard. You never know which is going to be failed. So if you will not take care of the corrosion part, you are going to lose maybe big, or you have the breakdown maintenance huge. Routine checks, hull and external structure. Yes, inspection, hull painting. If you have the round of blistering paints, rust streaks, and the pitting part. So what you have to do, you have to check on it and see that if it is not happening. Check waterline areas where oxygen and salt exposure fluctuates. You have the more corrosion part. So hull and superstructure, the regular maintenance is being required. That is your inspection and the painting part. And sacrificial anodes should be working correctly. ICCP should be working correctly. Ballast and cargo tanks. Tank coatings, yes. The ballast tank inspections, you have to see all these things. If any peeling is there, blistering is there, or the bare metal exposure is there, then you have to do the repainting part of it. The stagnant water or the sludge formation, cleaning part of it, so that the microbiological corrosion will not start. Tank inspection logbooks has to be maintained. Anyway, it is with the PMS system, we are maintaining that. And any the deterioration is there, then you have to report it. And of course, the sacrificial anodes also has to be checked. Sacrificial anode is also one of the important parts. Engine room and machinery, inspect the seawater cooling lines, pumps, and the heat exchanger for the erosion and corrosion part. Yes. Bilges for stagnant water, cleaning regularly required. You can avoid the MIC. Lubricants, fuel system, chemical contamination. Normal, the housekeeping practices will reduce the corrosion, I must say. Normal watchkeeping will reduce the corrosion part, I must say. So these are the something which is a very important. Deck equipments and fitting. Yes, the very much important is your visual examination. Winches, cranes, mooring winches, windlass. So you can see the joints, and yes, the mechanical wear is also there. Chemical exposure is there. You have the moisture oriented corrosion is there, seawater exposure is there, everything is there on the deck. Whatever the pipelines which is going, whatever the equipments which are there, you have to see all this. The fasteners you have to see, and whenever there, you have to change, replace it. Ensure the protective coating everywhere. So regular painting is being required for the deck equipments and fittings, and if required greasings and also that also has to be done. Preventive maintenance, cathodic protection system, sacrificial anodes, and impressed current cathodic protection, that is your ICCP, must be functioning correctly. The aft part, the forward part. If the recoating is required, touch-up painting is required, so that also has to be done. And ensure the ventilation in closed spaces. basically to reduce the humidity driven corrosion. So this is also very important part. You have to follow all this so that you can reduce the. And finally, the documentation and reporting. You can see the detailed record of the corrosion prone areas in the engine room. Any extra work or job has to be done, any inspection which is being carried out, so that the other person will be also aware and keep an eye on that. Report recurring issues to the chief engineer, and you must make a defect list and plan in the dry dock repairs. Track the inspection intervals to ensure no area is overlooked. So if you have the proper documentation and reporting either in PMS system, either in the logbook, then it will be closely monitored and the impact of the corrosion will be less. You can do the better corrosion. Thank you, all of you. I hope all of you have understood what I have explained, especially the routine maintenance you must carry it out to prevent the corrosion. Okay. And in the next coming video, I will be coming with one more MMD question which asked about the various types of corrosion and their preventive measures, how you can carry out. So that I will discuss in the video. Thank you.